Okay, so why is the derivative of an exponential function the exponential function times the log of the base? So why is d by dx of a to the x equal to a to the x log a? Well, it relies on the fact that d by dx of e to the x is exactly itself, e to the x. So we're going to prove this equation using this idea here. So let's say that we have f of x is an exponential a to the x. We can rewrite a to the x as e to the log of a to the x. Okay, so what we've done here is e to the x and log x are inverse functions. We've composed them. When you compose inverse functions, you get the input back. So e to the log of a to the x is exactly a to the x. But now we can use the exponential property of logarithms to say that this is e to the x log a. And now this says e to the u, where u is a function of x. And so we can derive this using the chain rule. So let's do d by dx of e to the x log a. Well, it's just going to be e to the x log a times d by dx of x log a. The derivative of, so this is a linear function. This is just some number times x. And so the derivative of it is just this number log a. And so we get e to the x log a times log a. But remember that e to the x log a is exactly a to the x. So this is a to the x log a. So that's why the derivative of an exponential is the exponential times the log of the base. So for example, what if we have something like 3, well, simple example, 3 to the x. Then f prime is 3 to the x log 3. But what if we have to use the chain rule? So what if we have something like f of x is, 3 to the 2x squared minus 1. Well, then we have to use the chain rule here, so that means f prime is going to be 3 to the 2x squared minus 1 times log 3 times the derivative of this quadratic up here, which is, 4x. That's it. All right, so there's a proof of why the derivative of an exponential is just the exponential times the log of the base, and a couple of examples.